This video will present the topic of slope-intercept form of a line. Previously, we've talked about the standard form of a line, which is of the form ax plus by equals c. The slope-intercept form is a linear equation solved for y, and we get y equals mx plus b. The coefficient of x when a linear equation is solved for y is always the slope, and the y-intercept is always the point 0b. So why can we say that when we solve an equation for y, that the coefficient of x is the slope, and the constant term is the y-intercept? Let's look at an example. Let's consider y equals 3x minus 2. And I'm going to go through and find some solutions of that equation. I'm going to plug in 0, 1, 2. If I substitute 0, 3 times 0 minus 2 is 0 minus 2, or negative 2. Replacing x with 1, I get 3 times 1 minus 2, which is 3 minus 2, or 1. 3 times 2 minus 2 is 6 minus 2, or 4. Recall that the slope is defined to be the change in y divided by the change in x. As we move from one point to another point in my table, the increments between the x values is a change in x, which is just 1 unit. As I look at my change in the y values, to go from negative 2 to 1, I've increased by 3. To go from 1 to 4, I've increased by 3. So as I see that, my ratio, the change in y divided by change in x, is 3 divided by 1, or 3, which is exactly what my coefficient of x was. My y-intercept is always a value we find when we replace x with 0. That is confirmed here. We get 0, negative 2. This is just one simple example, but this is true no matter what type of linear equation you have. When you have y equals mx plus b, you get the slope and the y-intercept. Now, what we're going to do now is write an equation in slope-intercept form and then use the information of the slope and the y-intercept to graph the line. This is exactly what the calculator does when we want the calculator to graph a line. We have to write it in the form y equals mx plus b. And I might add that when we have an equation of the form y equals mx plus b, f of x equals mx plus b is just a linear function where m is the slope and b is the y-intercept. We have the equation 3y minus 2x equals negative 6. So to solve this equation for y means we're going to put it in slope-intercept form. We first add 2x to each side to get 2x minus 6. To solve for y, we divide each side by 3. This gives us 2/3 x minus 2. The slope of the line is a coefficient of x. Remember that this is a numerical value. I see some students wanting to put 2/3 x as the slope, but the slope is just the number, the numerical coefficient of x, 2/3. My y-intercept is a point 0, negative 2. To use this information to graph, I like to tell my students, think of B as begin and M for move. We will always begin by plotting our y-intercept, in this case 0, negative 2. The slope tells us how to move to the next point. Rise divided by run is our slope. So this 2/3 means we need to rise by 2, run 3. From the y-intercept, I'm going up 2 units, and to the right 3. Up 2 over 3, plotting a point there. I can continue that pattern if I want to. I can also use anything equivalent to that form. 4/6 would work. Any ratio that is equivalent to 2/3. And this is a graph of the line. Now, of course, use graph paper, use a ruler to make sure your lines are straight. Example 2 is the equation x equals negative 2y plus 4. Writing this in slope-intercept form means we just want to solve for y. I'm going to rearrange these terms so that I get 2y plus x equals 4. Then subtract x from each side to get 2y equals negative x plus 4. And divide by 2. So y is negative 1/2 x plus 2. The coefficient of x, negative 1/2, is my slope. The y-intercept is 0, 2. To use this information to graph, we start at 0, 2 on the y-axis. Our slope tells us how to move. Have to be careful with a negative slope. Negative 1 divided by 2 is the same thing as negative 1 divided by 2, or 1 divided by negative 2, but it is not negative 1 over negative 2, because those negatives divide out to give us a positive. I have to think of the negative with either the numerator or denominator. I prefer to think of it with the numerator. Negative 1 divided by 2 then means my rise is negative 1 and my run is 2. But to rise negative 1 means I have to go down 1 and run 2, which is to the right 2. And I get to my other point. Example 3 is a little bit different. It is to write an equation of the line in slope-intercept form that passes through the point negative 2, 3 and has slope 5. To get this in the form y equals mx plus b, we know the slope, that is the value of m. We don't know the y-intercept, but we are given a specific point on the line which represents our values of x and y. We substitute those 3 values into the slope-intercept form, which will enable us to solve for b. In place of y, we put 3 equals m is 5, x is negative 2, and then plus b. This gives us 3 equals negative 10 plus b. Adding 10 to each side gives us 13 equals b. Therefore, the equation is y equals 5x plus 13.